Hello. We're going to get started now. So here we go. This is a great turnout. Thank you all for coming. This is the July show and tell for the Portland Creative Coders Group, which you probably already knew. Welcome. I'm going to run through introductions a little bit. My name is Ben. I'm going to be kind of wrangling people and speakers and that sort of thing. If you have any questions, feel free to grab me. We are streaming this live. It's going out onto YouTube and will be archived later. Keep that in mind. This is all being recorded, and the microphone is right there. Okay. The Wi-Fi, if you need to be on the Wi-Fi, that is the Wi-Fi over there. The food and drinks, hopefully you noticed already, there's the cooler back there, snacks on the table, help yourselves. Bathrooms, the sign all the way down the hall on the left, should be easy to find. And with that, I'm going to let Thomas tell you a little bit about Oregon Storyboard, which is the space that we're in right now. So thanks to them for having us, and here's Thomas to tell you what that's all about.
Hello, everybody. Thanks for coming. I work as an instructor, HoloLens instructor at Oregon Storyboard, and what we're trying to do is really bring AR and VR to the Oregon economy and do some workforce development around that. And also get people like you, as well as businesses, as well as the educational institutions, really excited about what we can do within augmented reality and virtual reality, and how can we make Portland and Oregon a nexus for that. How can we build an organization around that? How can we build an ecosystem around that? So that's what Oregon Storyboard does. Been doing it for 3 years now, 4 years. And the approach is through incubation. So we incubated a few companies, and now we're incubating through education and training. So what we're doing, we're going to later today, I'm going to show some of the work that I did, and I work with Ben and Reed and some of these guys here, around HoloLens Art Hack Day. So we organize those things to get access to that hardware out into the community and to get people to start thinking about that. We also have, and this is my pitch, so bear with me, we have professional training. So if you're really interested in AR and VR and want some hands-on experience, a day long with Vive, with the Oculus, with cardboard, with Samsung Gear, and with the HoloLens, Oregon Storyboard organizes every month. We do 1 or 2 or 3 of these day-long events. You can sign up. We have one on July 26th, and we have one on August 17th. I think they're $275 for a person, and I'm instructing it together with some others. And it's a great way to get some access and some thinking and some focus on this type of stuff, and it really helps Oregon Storyboard. So thanks all for coming, and let's get going.
Awesome. Okay, so what we'd like to do, if you've been to these meetups before, you're probably used to this little spiel by now. It's great to come together and see talks, but it's also great to meet people that are interested in the same sort of weird technology, creative space. So we'd like to take a few minutes. I will cut you off because people tend to get carried away, which is good. But if you all just kind of introduce yourself to your neighbor, especially if you don't know them already, say hello, that would be awesome. So maybe stand up, say hello, shake hands, introduce yourselves.
I know you guys. Oh, nice. Yeah. Well, yeah, it's okay, next. I had a friend studying I'm just trying to get into it. Are you Really good. Yeah, one of my friends contacted developer at agency that I came with, said really fabulous. And also, yeah, every time I mention, oh, it's a good one, the Hack Morgan folks, and like Cat Riley, they're like, yeah, it's like the best. Yeah, how long is it going to go on?
Okay. All right, stop saying hello. This is what stop saying hello.
Never worked.
Awesome. Now we all have friends that we can talk to after the talks and say things like, why wasn't that a thought-provoking talk? What did you think of that talk? All right. So tonight we're going to have 3 different 20-minute, hopefully, unless we go over, which I guess that might happen, 20-minute talks. We're already 7 minutes over. I try to pay really close attention to the clock, and I never make it. So the first one is going to be Josh Michaels, who joins us today to talk about neural networking and like visual style transfer, which is fascinating. A lot of people are doing some incredible stuff with that, so I'm really excited to hear about that. I hope you are too. Then next up, we're going to have Philippe teaching us about debugging, kind of getting into the world of making your code work better, faster, and hopefully with less console.log debugging. And then Thomas will be telling the group about the HoloLens Hack Day that we did a while ago, with some cool live demos as well. And then after that, all your new friends that you have met just now, we can all hang out and drink beers and talk about nerdy, creative stuff. And then we all have to leave. All right, the presentations. First up, we're going to have Josh Michaels tell us all about this crazy neural network stuff.
Cool, thank you, Ben. Yeah, and what do we do with the laptop to just like...
I'll just swap it out.
And where's the adapter?
Right here.
I don't have that. I can get mine.
Just do this. I'm going to try really hard not to spill my beer this time. I put it right under there where I spilled it last time. And learned nothing. Yeah.
Hey everyone, so please don't read the text on the screen. This is going to be more of me talking through some notes and giving some examples. I do want to point you that this document that I'm sharing here has links to every piece of code, every app, everything I'm going to talk about tonight. So my guess is after you hear this talk, you're going to be like, I really want to go home and try this stuff. And if you just save this link and you go home, everything I talk about today, GitHub references, apps, everything is linked to from here. So this stuff is really cool. I just started playing with it about 6 weeks ago. And it was one of those things where as soon as I saw it, I was like, I have to understand what's going on here. I have to figure this out, and I want to play with it a lot. So bit.ly/pxstyle will get you to this document, and I'm just going to be talking through this and giving a bunch of examples and some demos of stuff that I've worked on. So to start off with, is anybody here familiar with style transfer, has played with style transfer, is aware of this? Okay, cool. I'm impressed that there are people who knew. I was unaware of this. I guess it's been around for about 8 months, 9 months at this point. It came out around the time of Deep Dream. Are there people familiar with Deep Dream? And okay, so that's amazing. So kind of Deep Dream got around as one application of neural networks for making art. And shortly after Deep Dream came out, this other technique came out, which is built on very similar technology, which allows you to take one image and apply the style of any other image to it. Now, what is style in this context? Well, it turns out in this context, they boiled it down to a mathematical equation. So it's really hard to describe style as one thing or another. But from playing with this, you can start to see the power of it. So I'm going to start off by taking you to the GitHub project that started it all. This is a project by a researcher out of Stanford, J.C. Johnson, called Neural Style. And this was the first open source published implementation of style transfer. And you can see some of his examples here where he's taken Starry Night from Van Gogh, and he's taken this photo from the Stanford campus, and magically the AI is able to produce this image, which seems to have characteristics of both photos. Some more examples as you go down the page, and again, this is all in his GitHub, where you take one image and then you take a style image and you apply that style to the photo and you get really magical results. Now, the thing that boggles my mind here is even the people who wrote the original papers on this don't understand why it works. They just understand that it does work and that the mathematics behind it just happens to make it possible. So if you're interested, and again, this is linked to from the doc, all of this goes back to this paper, Neural Algorithm for Artistic Style, which presents this information in a scientific context, but it was J.C. Johnson who took it and turned it into something that anyone can download, play with, and make this magical stuff happen. So I promise you by the end of this, I'm going to tell you how to just do this with your phone. Doing it by downloading the code and executing it yourself is much more challenging, but I figured there were people who came here today who wanted to know kind of like the complete picture of how this works, because doing it with the code gives you a lot more flexibility than if you're doing it with one of the pre-made applications. So these are just some examples. The limits are endless here. You can pick any kind of image you want as the style and apply it to any kind of image as the content. You get all sorts of weird, strange, and interesting results. Surya posted one of the Slack channel today where he used a dollar bill as the style. I saw one that used motherboard as a style, which I also thought was compelling. So you don't have to use a piece of artwork as your source style. You can use anything that you want to, and then just see what the AI ends up doing with it. So let me explain for a minute what's going on here, and then I'll go into some more examples and show you some of the apps and tools that you can use to play with this. So I don't have time to give a class on neural networks today. I'm going to provide links, and they're at the end of this, to online courses that you can take. So if you are interested in learning all of the details about how this works, there are a number of videos I linked to at the end here that you can follow that do a great job of explaining it. I'm going to give you a very naive and quick explanation to try to give you some context for what I'm about to show you. So in neural networking, it turns out that there's this concept of transfer knowledge, which has recently kind of been discovered or is being played with. And one of the hardest things with neural networks is that they require you to have a very large set of data to train the AI on. So you need thousands, millions of photos. Whatever it is you're trying to train on, you need a very big set of information. So if I wanted to train an AI to paint a Van Gogh, I would need thousands and thousands and thousands of Van Goghs to train the AI. Well, it turns out there aren't thousands of Van Goghs. There's actually very few Van Goghs. So how do you train an AI how to paint in a particular style without training it with a very large set of examples? Well, it turns out that transfer knowledge is the way to do this. And what you can do is take a network that's already trained on something similar for image processing or recognition, take off the most specific details in that network, and then apply it for more general cases. And what's being done here is basically a very large neural network has been trained based on a set of images, and then the most specific parts of that network are being cut off, and it's being repurposed for all different kinds of art. So that's the most detailed I'm going to get here today, but the thing I want to bring up is that this is very similar to metaphor, right? So if you already know Final Cut Pro, for example, which is a video editing tool suite, you can very quickly learn Premiere, right? If you know about one concept very broadly, there are many other concepts that that knowledge might transfer to. So this concept of transfer knowledge as used here is interesting in the computer sense, but we do it all the time every day. Our brain works the same way. And part of my fascination with this area has been these correlations between how we actually think and how this code works. So this is based on this concept of transfer knowledge where you pre-train a network, take off some of the details, and then use it for these more general cases of transferring style. So let's see if there are any more details. So the math underneath it is this thing called the Graham matrix. Is anyone familiar with this? It's similar to dot product. Doesn't really matter. It just makes the magic work. And you know that they take a very similar position in the paper. So I first learned about this about 6 weeks ago, taking a course when I was in New York that taught exactly this. I'd never heard about it previously, As soon as I left the class, I went home and I spent pretty much the next 4 weeks doing nothing except playing with style transfer because the whole concept of this really intrigued me, and I just wanted to see what it could do. And I'm going to show you some examples now of some of the stuff I played with, and what I've been playing with is this new technique of video style transfer. So this just came out about 2 months ago, and you can imagine that if you can style transfer one image, then you could style transfer a sequence of images to make a video. So say you've got 500 frames of a video, you could style transfer them each individually. However, you'll lose cohesion across those frames if you look at them one at a time. So what this new project has done, Artistic Videos, which is based on J.C. Johnson's project, has added a component to track the visual flow in the image. So it's not just individually looking at each image and doing the transfer in the video, it's actually maintaining the flow in the images across the sequence. This makes it possible to do video without it jumping around. So let's just get into the pretty stuff, because of course that's what's hot. So here is the first sample I did, and this is just a very short clip of the Earth from the International Space Station. Can you guys all see that? Yep, so to start off with, I started with a short clip because this stuff takes a really long time to process, and I did not want to waste a bunch of time on something I didn't know that was going to work. So I took that video, and I took this photo from Monet, and I put them together, and here's your result. So this is literally the very first experience I had running this. And I saw this and I was like, whoa, wow, that's something, but it's not what I expected. Like, is this what you guys thought would show up? Like, I wasn't sure what I was going to see. So from that, what I started to think was, well, maybe I need to be transferring to an image which is really in close alignment with the style that I'm using to transfer from. So the next experiment I did, again, I took the image from Monet, but I took this video from Paris instead, so you guys can see that. So this is a full sunset time-lapse from Paris, and I transferred that Monet image onto this Paris video. And let me show you the result of that. So you'll see there's some weirdness going on in the corner, and that's some of the results of the flow tracking. And again, this didn't come out at all like I thought, but it still came out interesting. And that's what I really like about playing with this stuff. You don't really know what it's going to do. So I looked at this and I was like, okay, this is interesting, this is cool, but the thing that I really wanted to do is have it like maintain some of the color of that original image. Like, I'm trying to paint a sunset, so I wanted to show the full spectrum of that sunset, right? Well, at the time I encountered this problem, it turned out nobody had solved that issue of how to retain the color when doing the style transfer. And then, like, the day after I hit the problem, someone released code to do it. And that's what's like super exciting about this space right now, is that there's so many people kind of very aggressively in it, that if there's something you encounter where it's like, I wonder if that's possible, if it hasn't been done, it will be soon. So right as I hit that problem of, well, how do I recolor it, new code got posted. And so this is a recolored version. And you'll see there's pros and cons to both styles. But in this case, I've retained the color of the original while transferring the style from the first. So again, I wouldn't say that one was better than the other. It's just two ways of doing the same thing. So this color maintenance is now just built in to that first code project I showed you. When it first came out, it was published as a separate project, but now it's just a parameter on that first project that I showed you. So nothing special you have to do there anymore. That's just built in to the code that you get if you pull this down. So next one I did, I really started to try to align the style and the content I was transferring it to. And I really wanted to do something with Starry Night because that's like one of the coolest things that you can do something with. You see example after example of Starry Night done in X. But I wanted to find something that really I felt matched Starry Night, both in terms of color and style and structure. So I found this time lapse I had of the Golden Gate Bridge. And I thought in general the layout of the photo was pretty similar, with kind of the hills here and you had the bridge here. So I felt like this was going to be a pretty good example. And I spent 2 weeks on this. And I'll tell you, I don't like the result, but I'm going to show it anyway. Because part of playing with this is that you try one, it doesn't work, and you're like, huh, well, let me try something different. So Here is the result. So what's interesting here is you see the clouds kind of jumping around in the corner. And what I figured out is when there isn't good movement to track, it like hallucinates movement. So in this case, it doesn't really know what's going on, so it's making stuff up and then it's amplifying what it's making up more and more. So I didn't expect that to happen, and if I were to do this again, I'd probably change the parameters to put less weight on that flow tracking. But again, this is a full sunset, but the colors are maintained in this version. Here is it recolored. And again, I really don't like the way this one looks recolored, but it's interesting to see how it can work. So you're starting to get a sense of what you can do with this. There's no limits other than CPU and money. And that's, I think, the hardest part about doing these is that they require a graphics card with a very large amount of memory. Kind of the lowest amount you can use is a graphics card with 4 gigs. I'm doing it on an ATI card with 6 gigs. The people who are doing it professionally are using this NVIDIA card Titan X, which has 12 gigs on it. But the only thing that prevents me from just making a huge number of these is that this one took about 7 days to render. But there are new, faster techniques coming. So how much time do I have, Ben?
Hang on. You have 5 minutes.
Okay, so I'm going to blaze through a couple of examples, then show you guys some more links. So I continue to play. Here is a Renoir Seascape. And then I applied this video of a glacier from Louis Schwartzberg. Again, I thought the palettes matched and the structure matched, so I thought I'd get a pretty good result, and I did. I like the result on that. Okay, so here's my favorite one. So it took me 5 that I thought were okay before I got to the one that was like, I was like, okay, this is really good. And then like 5 other ones I threw out. So I went through 10 of these before I got to the first one where I felt I was like genuinely satisfied with the result. So here's a painting from Renoir that I'm using as the style. And here's a video of Lake Tahoe. And now I'm bringing in motion control camera action as a way to put in some motion that's subtle and give it a little bit more movement to be happy about. So I picked a style image which is kind of similar, and here's the result. So this is the first one that I was like super happy with, and I saw it and I was just like, wow, that's really what I was going for. So this is about 4 weeks into being obsessed with this when I finally produced one where I was like, okay, this is what I'm going for. And I'd hope that once I figured out one that I really liked, like the next few would be good too, but they weren't. But I'll show them to you anyway. So this one I took Pissarro fields. And I was like, I got a bunch of time lapses that look like this. This should be easy. So I put it together with this time lapse. So you see there's a little bit of motion control camera movement there. And I thought, I was like, these line up really well. Like, that should do well. But the AI had a hard time distinguishing the sky and the ground, because it doesn't know what's sky and what's ground. It's not thinking logically, objectively about, well, that's the ground, so I'm going to paint it with the ground. So here's the result, and it's not terrible, but it's not at all what I imagined. Okay, so those are some of my demos. If you come up to me afterwards, I've got some more, and I have them running on my phone in an interactive way that you can play with them. I don't have time to show that to you because I want to give you guys some more info on how to do this yourself. So anybody can do this. What I'm doing here with video is hard. It will take a lot of time, and unless you're super psyched about the video concept, I would avoid it for now until the software gets a little bit better. But the single image style transfer anybody can do. So the simplest way to do this stuff is with apps that do it all for you. This app came out in the last week, Prisma. Has anyone heard of this or seen this? So this just like blew up the charts, like instantaneously. It's crazy. I haven't seen an app, a photo filter app, blow up the charts like this since Hipstamatic or Instagram. And what they did that was different from Dreamscope, Artify, and 4 other apps that all did the same thing for the last 6 months is that they made it completely free. So they're just sucking up the cost on the server side to do this. I don't understand how those economics work. There are some business models where you just spend a ton of money and then hopefully money comes out of it. So I don't know how they're dealing with the fact that they're generating millions and millions and millions of these a day and not making any money. But you can take advantage of that by downloading the Prisma app onto your phone, and that will just let you instantaneously start doing this with images. Now, the limitation of Prisma is that they use this new technique, fast style transfer, which is based on a new code set which takes a tiny, tiny, tiny fraction of the time to run of the original one. And the difference is with this new fast approach, they take that pre-trained network and cut out all the parts that aren't relevant to the particular image you're transferring. So that lets you do it way quicker, but then that can only do that one style. So Prisma won't let you pick your own style to apply. You have to go with one of the 15 styles that they give you, and that's the way it's always going to be because that's how their app is set up. But my guess is if you really want to play around, you're going to want to try your own styles. So the easiest way to do that is deepart.io is a web-based way of playing with this. They offer video at 250 euros a minute. So they show this on their front page, and it's like, yeah, 250 euros a minute for 720p video. But that's actually cheap. It was like half of what it was going to cost on Amazon to do the same thing. So, but these guys basically exact same backend as I showed you. They just do all the work for you. You upload the images, you're done. So if you want to do it on the web, deepart.io. If you want to do it on your phone with a little more flexibility, Dreamscope is another app that came out well before Prisma, and Artify is another app that came out well before Prisma, which offers more flexibility. But with all of these, you can either do it with the web, you can do it on your phone, but anybody can do this. So if you want to just play around, I encourage you to try out some of these apps. If you're intrigued by the apps, then I encourage you to download the code and try playing around with it and see what you can do. And if you have any questions, feel free to ask me. Just to wrap, in this document, everything I learned about this, I learned from taking this class, which is amazingly up on the web. So everything I know, you can go learn in 3 hours by watching this video. Or if you want to know more, there's an entire 6-video set from the same person who taught the class I took that explains every single detail about what's going on here. So if you find this fascinating to the point that you're like, I want to know how this works, I want to know all the details, that's how. So read. So this is exactly something I've been playing with. And so MC Escher is a perfect example here. So Escher's work, the style and the content are very deeply intertwined, right? And if you look at style transfers done on MC Escher work, they just don't feel right because they get like his coloring style, but they don't get the shapes. So one of the things I've been thinking about doing is basically taking an original Escher, making a 3D render that's just flat sides that matches that Escher, and then making a video of that and transferring to that video. But I think that's the thing that I'm doing that I haven't seen many other people doing, and I think is the key to some of why my stuff looks good, is I'm thinking very seriously about the source material and the image I'm transferring to and how they relate to each other, as opposed to just throwing Starry Night on everything I can find. And I think if you think creatively, just like you're talking about, where you're like, well, I can, you can basically reanimate an old piece of art by creating a 3D frame to put under it and transfer to, which I think is along the lines of what you're describing. So this is wide open. Like, there's so much you can do here, and very few people are even playing with this because it's been so inaccessible historically. But now with Prisma and some of these apps, it's becoming more accessible. So I hope you play with some of this stuff, and if you enjoy it, I hope you go deeper. And again, this document that I put up has literally everything you could possibly need to get started or get the source and do this yourself. So, yeah.
When you said that one render took 7 days, do you mean like seven? Like
7 processing days, 24-hour processing on one GPU.
Does the software support like starting and stopping, or doing it like in parallel?
Yes, and what's amazing, it does support starting and stopping, but I didn't find that out until after like 4 failures. So like my first few, I had to redo them. The video stuff, nobody's made that work on a Mac yet. I hacked it on my Mac, but there's no like prescriptive way to do it. I just kind of kept going until it worked. So I didn't even know how fast it was going to be. But yeah, on my Mac Pro with ATI D700, 6 gigs. I can do about 1 frame every 10 minutes with the standard approach. But with the fast approach, I can do about 10 frames in 1 minute. The fast approach just isn't as flexible and the quality isn't as good. So you choose your trade-offs.
Yeah. Any kind of distributed rendering system?
So they've tried to do all sorts of parallelization here, and it just hasn't worked out. And the key is that the whole model has to be in memory on the same GPU for it to work. So by slimming that model down is how they made it go faster, and that really helped. But it's still like there are parts of it which are parallelizable, but I'll tell you, I ran 2 instances on 2 different GPUs isolated from each other, and I was like, this should absolutely work. There's like no excuse why this doesn't work. They were isolated in different directories, and they kept causing each other to crash, and I couldn't even explain it. So, you know, it's from everything I've read, basically, it's not easy to parallelize this, but there is some work on tiling where there are attempts at basically doing higher resolution by rendering tiles and putting them together. And one of the links here goes to a Mike Tyka project that does that. But this is wide open. This is the thing, is like, this is just, anyone can go make progress on this. Like, there's a couple hundred people in the world hacking on this, but now there's millions of people playing with it, which is phenomenal. So, cool. Any other questions? Yeah. So I would encourage you to go experiment. I will tell you, I saw a performance 6 weeks ago, actually at the same conference where I learned about this stuff, where someone had made an instrument using a neural network. And basically what they'd done is trained a network with something like 10,000 samples of various instruments, and then they live coded to change the parameters of what sound to play from that network at any given time. So like how big of a cluster to look at, how many sounds to play and what frequency. So they basically trained an intelligent instrument that they then dynamically coded in real time in order to create their performance. So that's how kind of at the edge some of this stuff is. There's no shortage of ways that this might apply, but what we're looking at here is a new technology which we're only really starting to understand. And I think over the next 5 years, we're going to see just example after example after example where what's going on with convolutional neural networks is just going to completely undermine the way we used to do certain things, and new ways will come about. And that's starting to happen right now in all sorts of industries. Language translation is one of them, where like the way we do language translation 2 years from now will probably be completely different from how we did it 2 years ago. So it's fun to play with this stuff on the edge, and like anyone can do it is what's super exciting. So cool. Well, thank you for your time. And again, if you have any specific questions, come up and see me. And this document tells you like everything you need to know. So bit.ly/pdxstyle if you're interested in going further. So thank you very much.
Thank you. That was crazy. All right, I'm not going to hook my laptop back up. This is Philippe. Philippe, I will butcher it if I try to pronounce your last name, so I will let you introduce yourself. And now we're going to learn about some cool sort of intro to debugging so that we may debug more effectively, or in some cases at all. All right.
Awesome. Thank you. So hi everyone, I'm Philippe. I'm a software engineer at Second Story. I'm a studio intern, and today I'm going to talk to a subject that is really actually dear to my heart. So it's like debugging. I think it's really important. It touches like every programming language that you ever like tried, and as far as I know, it's not the thing that's it's really powerful, but it's not really taught well or often in for like beginners or like creative coding. Like for instance, like processing didn't have debugging feature until like the version 3. So I was like, I want to share with you like some of the stuff I know about debugging and some of the stuff I love about it, and hopefully you will it will be helpful for you. So debugging, what would that be? Good thing it's just like I'm going to troubleshoot some stuff, but it's a little more complicated than that. So it often starts with like, oh no, something is not working. What should I do to fix my code? So sorry. So I would be like, oh yeah, we can put like some console log everywhere, like oh print the variables in the console, or oh is this code is being run. That's a form of debugging, but that's kind of rough, and maybe we can do something better. So instead of doing that, we can take this approach of like, we're going to think about problems that could arise in our code, and find like where we can test these points, and then test these like locations, and use like tools for assessing what's going on. It's a bit like science, where like you're making some hypothesis, and then you're going to see like, I'm going to, maybe that's wrong, and then I'm going to like look for the truth. Like, is my observation match what I'm what I'm thinking, and is it like, and something else that you can do is like all this like debugging like tools and method is not only like you're trying to solve something that doesn't work, but you can be in a situation where you have like a complex system and you don't really know what it's doing, and you can use the same methods to understand what's going on. So let's say you have like a piece of code, you don't know what it does, you can walk through with a debugger and like have a better idea of what's going on. And another one that it's getting a bit more edgy, but you can use debuggers to uncover like undocumented APIs, for instance. Like it could be like, oh, I wonder how this Prisma application works. Maybe you could use a debugger to look into it. That's probably against the terms of utilization of this app, so don't do it. So for this presentation, I would say that like debugging in general is this like a set of tools and methods for you to get an idea of what's going on under the hood, either for your understanding or like fixing problems. So the outline of my presentation is like I'm going to talk about debugger, which is like the main tool for debugging, I guess. And then I'm going to present like other tools that are also like really relevant for that. And after that, maybe more tools that are I won't have time to like demo them or whatever, but it's good to know that these kind of things exist. So next time you might need some, you can go for it. So a debugger is like it's like a tool for observing what's going on, and it can also like affect the flow of your software. That is to say, at some point you can say, okay, we're going to pause the software right now, and we're going to look at like what's going on, the variables and all that stuff, and see, get a snapshot of your software at a given time during its execution. And you find it for like everywhere. That's like a scary one. It's called JDB, and you have it for everything. You can see like a bunch of assembly stuff. I'm not going to show you that today, but it's just one of the examples. Some people are like afraid of the command line tool, so they build like interfaces that are also like super complicated and noisy. That's one on Windows, so it's on all the platforms. That's Xcode. This one is nice because if you see in the bottom part of the screen, you have some source code that you can see. So it's getting like one step better than like assembly, and even beyond that, even in the web, this is like the Mozilla like debugging tools. So you can use it for like debugging your JavaScript code. So what's the how do you use like the debugger? So you have like different concepts, I would say. Like the first one is like the breakpoint, which is like a place that you mark inside your code that says, okay, when the execution reaches that point, we're going to freeze, and the debugger is going to show up, and then you can do like interact with the debugger and have like better ideas. Beyond that, we have like once it's frozen, you can either like resume the course of the application, or like try to run like instruction by instruction to see what changes, which can be useful when you're trying to learn programming and you want to have like a better view of what this function does to your software. And memory watches, which is like if you freeze your program and you want to know like what's the value of this variable, it's going to show it, tell you. So I'm going to show you like a demo of like a little Lactoy app that I made, which is like it's like an open formats app that's doing something really simple. So I made this. This is paint, but I made this like black and white images, and there is like a red pixel here. And the OpenFormworks application is just meant to count the number of pixels that are white and that are black. And unfortunately, it seems that it's not working, so we're going to go through that. So yeah, you can see it says here that you have like 0 black pixel and there is no like white pixel, which is, I would say that's not the case. So we can investigate how, why. So this is like the main function of the drawing function of OpenFormworks here. And I'm going to click in the corner to set a breakpoint. So it freezes immediately because like this function keeps being called at every drawing loop of the app. So the software is frozen here. We can see that that's the function that counts the number of black pixels. Right now I'm going to click on step over, which means that I'm just going to like jump to like the next instruction and see what's going on. So here we can see that now it says there's 0 black pixels, so that's really like not what I want. So I have like an I press like the key to like continue the execution of the software, and it reached breakpoint again. But this time I'm going to step into the application, so I guess it's this one. Step into the function, sorry. So, and so I think for now on I'm going to use the key on my computer because it's a bit easier. So we can see here the function is like, so we have like 0 black pixel, and then we have like some sort of like for loop that is counting, just like checking the pixel here, and then like if it's black, it's going to increase this number. So we may wonder, is this call ever executed? Because it says 0, so I'm like, it's confusing. So I'm going to put like a breakpoint here and ask the software to run to see if it breaks there. So it does. So that's interesting. So the software finds that, oh yeah, we have some black pixel, and I'm just like running it like many times. You see the arrow like here indicates like which time we're executing. And so you see it keeps like counting it. Now it says like there is like at least like 5 pixels that are black. So it's running the stuff. So I'm just going to quit this this loop. So now like the loop has run on all the images, the whole image, and it says, oh yeah, we have like a lot of pixels. So why doesn't work? So here we have like a function that would say, oh, if we have like 0 pixel, it will like log an error message, and yeah, that's not executed. But if now I look at the value, it's changed to 0. That would be like where the bug is. If you know like C++, you would notice that I messed up this if function, and what's happening here is that value gets like reassigned because there should be like 2 equals and not 1. So if you're like running into like a trouble and you're like, oh, what's going on? You could find, oh, that's where like the bug was. So if I add like an extra like equals here and quit the app and restart it, it's like recompiling. That's the cool thing with like C++. It takes a while. So I'm going to remove the breakpoints so we can see what's going on. And so now we see that the value is like what it should be. I think we can get it so like we don't care about the white pixels. So I think what I try to demonstrate here is like how you can go through like a piece of code like step by step and look at the values in memory, and that's how you can exhibit like some weird behavior. Like I never wanted that number to swap from like a high value to 0. That's not intended. And by looking at what's going on, I could find out what was the bug. So there's like more stuff to it. You can set like conditional breakpoints, which would be instead of breaking like every time that the code is being run, you can instead create a condition. For instance, I only want to break if the pixel is red. That's why I have like a red pixel in the thing. So it's useful to know about it if you don't want to debug like thousands and thousands of iterations. You can also do memory inspection. Let's say you wanted to look at how the image is stored in memory. You can ask Visual Studio or like some of the software to show you what's going on. And also that's more like for more advanced user. Sometimes what happens is like the software works really well on your machine in the dev environment, but it crashes like in production. Like I don't know, you deployed it to a client and it just crashes there and not on your machine. So you can, I think that's more like for C++ developers and maybe like C#, Java, and etc. You can create like crash dumps, and then like import these crash dumps into like your debugger, and it will show you where it crashed. Maybe with not as much information as you had before, but still it can tell you how it crashed on that line, and maybe there were like this type of variables like allocated at this time. So sometimes it can make the difference between I have no idea what happened to actually it crashed here and probably like something wrong in this area of my code. I think I'm going to skip like the second demo. You get the idea. So another field is networking, and in more general, like we looked inside our code what was going on, but sometimes instead you want to see like you have your software and you want to know what's going on, like from like let's say the internet towards your software, or like what your software is sending, and the internet, or like I don't know if you have like a Raspberry Pi talking to like an Arduino controller or something. You may want to like monitor what's going on the wires, so that if something doesn't work, you can have like ideas of where to start looking. So that's one of the few use cases. Or like another one is you have like this application that's running on your machine, and you know there is an API, but you don't know what the API might be private. So you can like monitor like what's the communication between that software towards the servers, and then maybe you can use it for making your own like client or something like that. And the tools of this trade, I would say like Wireshark is the most important one, and I'm going to show like a really quick demo of that. Netcat is like a really handy tool that runs on Linux, Mac, and it just lets you like it's like a command line tool that lets you create like a connection. And then you can, like a socket connection, either like a server, or you can connect to a server using Wireshark, Netcat, and type the commands that you want. So it's useful for like just like trying to send like raw data by hand. Sometimes it's useful. And for the web people, you can also use like for instance, like the Chrome tools to like look at the network traffic and so on. So I'm just going to show like some really like the most simple like Wireshark like thing. Let's go for it. So on this example, I'm just curious, let's say. So I have this page. It's just like a basic page, and I want to know what's going on when I refresh the page. So let's say an example could be like I want to make my own web client, and I don't know how web works. So I'm going to ask Wireshark to record like the traffic going to my machine, and then we're going to like look at just what it does, like really quickly. So this is Wireshark. I've selected like my Wi-Fi interface, and I say that I want to start like capturing packet. So I click on start here, and like really fast you're going to see like a lot of stuff. Maybe not. You should see a lot of stuff. I don't know why it doesn't work. Let's see. Oh yeah, okay. How do I clear that? Okay, so is there like a filter? That's what I wanted to show you. So this is like all the stuff going on when my computer is on the network. I don't know, maybe Skype is like checking updates or something. I don't know. But you can create like filter to like get like all this like mess away. So for instance, I want to like look at what's the traffic between my computer and this like website. So Wireshark has like 5 filters that says, oh, you have like this protocol or this port or whatever, and you want only that type of information. So I say like HTTP because it was like an HTTP request, and the host of this request was okay. It's going to be hard, so and so now I'm like filtering that, and I see there is only one request, because when I press like refresh on my computer, and what I would expect to see here would be like the whole like page would show up, and so you can ask Wireshark to follow the communication, and so you can see that actually that's not what's going on when I'm trying to ask this page on GitHub. So the red is like what my computer sent. So if I wanted to reproduce this request, I could just like copy and paste all that and send it like in a raw socket. And that's like the reply of GitHub. And so like, which is interesting to me that I really did not expect before like showing that to you, was instead of sending me back the page, it just says, oh, you already have the right page. I was like, oh, that's interesting, how does it know? And if you look here, you have like this request that says, oh, I've already like cached the version, and it's if like the page doesn't change, you can just like send that to me. And honestly, like I didn't know you could do that in web. Just by looking at this stuff, like right now, I was like, that's what I discovered. So the point is, you can use this tool to learn like more stuff, and that doesn't only need like, it's not only like TCP, it's not only like web. You can like monitor like OSC messages, or I don't know, like you can do like phone over IP. It's really like it's all over the place. It's like a really powerful tool. But if something doesn't work on your machine, sometimes it helps to like try to look like, oh, am I receiving the packet I'm thinking I'm going to receive, or am I sending the right request that I'm thinking I should be sending? So that's Wireshark. Yeah. And just like to brush out like more tools, so that if you ever in the need, you know that this kind of stuff exists. If you want to make sure that your application is not using too much resources, or is it using like the resources you think it's using? On Windows, you have like Process Explorer, which is really nice, and it tells you like, you can see like the usage of like CPU or GPU of your app. So I don't know, let's say you install this new like Adobe application, and it's like super sluggish, and then you can be like, oh, maybe it's not using my graphic card properly, and so you can check that and see like if it's have like a high GPU usage. It's just like an example that's kind of like lazy. And you have like profilers, so like let's say you're making like an OpenGL application, you can download the Insight from NVIDIA, and it's going to tell you, oh, you're running like that many calls of that stuff, and it's taking that much time. So if your application is sluggish, that might be because that call is like messing with everything. So profilers are like another way of looking into what's going on with your app. And this one is kind of my favorite, compilers, which is, let's say, you have an Android application or Unity application. Supposedly you lost the source code of it, and you want to get it back. So it's supposedly like complicated, but with this type of tools, you can pick inside like a compiled application, and it gives you something that's really close to the original code. So once again, supposedly you're like only doing that with stuff that you own or that you're like allowed to reverse engineer. But once again, like let's say you want to understand how the Pokemon Go application works. Probably you shouldn't, but you could use these tools to like reverse engineer the stuff and look at what assets are in it, see if you want to get like the image of the Pokemon, or if you want to see which API you use, etc. So that's sometimes useful, and that's what information security people use, for instance, for like when they're doing their work. So there's like a lot more to that now. And there is hardware too. I just talked about software, but if you want to debug, I don't know, like your router, like a modem or something, you can open it up and plug like a JTAG debugger, and it's going to give you like an interface, like the GDB stuff I was showing you. So you can, instead of running your like breaking putting a breakpoint in your software, you can be like, I'm going to put a breakpoint in some code that's running on my modem and see what's going on there. Sometimes it's useful. And then you have like more stuff like logic analyzer can be used for like, let's say, you're having like this LED project with like Arduino and it doesn't work like the way you expect it to work. So you can like put like the clamps on the wires of your LED strip and see like what the Arduino is sending to the LEDs, and you can compare that to what you would expect. And oscilloscope are like kind of like the base if you're doing like electrical engineering. So I think with this talk, what I tried to share with you is there is like a lot more that you can do beyond like printing stuff in the console. So it's useful for you to like solve your like debug your application, but also it's like a learning tool for understanding how things work and what's going on. And also like sometimes it can be like an opportunity to see what's hidden in application and maybe use it for like some art purposes. Do you have any questions?
I just wanted to say, I was talking about the Prisma app in the last presentation, and as soon as it came out and I found it, the first thing I did was break it open and decompile it, because I wanted to know which of those open source projects they were using or if they were doing something else. So I think Philippe was shying people away from like going after code that's not yours, but there are many credible cases where you have a binary and maybe they're stealing something from you. Like maybe they took an open source project they didn't have the rights to, and you want to crack their binary open and see if there's any indication that they actually took your project without crediting you. So I guess +1 for deviance with the tool.
Yeah.
Debugging serial ports, serial, will Wireshark do that, or?
I think if it's like running on your machine, if it's like serial from like your computer to like some stuff, I think it could. Or you have like, I think you have like other tools that like basically put themselves on your like as a Windows driver or like a Linux driver that's going to intercede. And I would think that Wireshark can be like an interface that get data out of these like drivers. Like I installed a new version of Wireshark and it wanted me to install like a USB something driver that's I guess meant to like snoop over like USB communications.
Also, a lot of consumer electronics have like diagnostic test points that are connected to UARTs. In like we're doing like sort of QA and quality control, and so they'll just leave those solder pads uncovered. And so a lot of times you can just poke around with like the TX and RX pin and just start getting data out. So it's pretty good.
Do you know if Wireshark does Bluetooth?
I'm fairly certain it does. Basically, you can people can create like custom like I think it's called dissectors for Wireshark. So that's the step that's going to like interpret like raw data from whatever into like to make it match the specs or whatever. So I think I've seen Bluetooth for Wireshark. I mean, really, like it's really all over the place. Like some, yeah. So I would say most likely yes.
A lot of these things use they can use a man-in-the-middle attack for decrypting encrypted stuff. You just have to make your test system trust the bogus certificate.
Yeah, that's correct. Like I think sometimes they try to avoid that by how do you say doing like certificate pinning. Like if you try to do that with Chrome and you might try to mine in the middle like Gmail, Chrome is going to be like no, that's not the right certificate, and then you get into like you can use like a decompiler or like a debugger to like modify the software itself so it doesn't do that anymore. It doesn't like make sure that's the right certificate. Yeah.
With the project called HackRF also that lets you listen to any of the software design radio, you can listen to anything from 1 megahertz to 6 gigahertz.
Yeah, I'm pretty certain like people also use like the HackRF to like feed it back into like to do like capture like, and then like I think they were like hacking it's called the LTE probably, and they made like their own like LTE stuff for Wireshark, and they would like feed like stuff from like RGRF or this type of software train radio. Any other question? Yeah, thank you.
The Chrome dev tools have been getting really good. You can actually break on attribute change in the DOM now too, which is crazy. So if you want to figure out who the hell is modifying some attribute in your DOM, you can just break on that stuff. It's crazy. What is going on here?
Cyborg!
And on that note, this is Thomas Wester. He is going to be talking about the HoloLens Hack Day that we did. If he can hear us, I don't know. He might be
I'm in a different world.
on a different plane.
Let's see.
Oh, HDMI is down there.
No, it isn't.
I guess I get help. There you go.
This is the future. I call it bent reality. Bent reality instead of mixed reality or augmented reality. I think we should really get into bent reality. And of course, it's not doing what I wanted to do right now, which is recognize this space and show a whole bunch of stuff. Because what happened is we changed the space, and so now nothing's going to work. What I would like to show you guys is just generally for those of you that haven't seen what a HoloLens does, is it's a webcam. But it has the ability, magical ability, to place things in space and keep them there. So the simple application that Microsoft provides is called holograms. Microsoft's calling it a holographic computer. I think it's, I'm not sure about that name. So if I want to place a space shuttle up there, I can. And then I can, if I weren't tethered, because of Wi-Fi issues, you see, see now it sees the whole space. Look at all the things that recognize the space. So it's the ability to actually place things in the physical environment, which Microsoft's calling mixed reality, or you can think of it as augmented reality. Pokemon Go is doing us a huge favor in helping people imagine what augmented in the future of augmented reality can be, both in a good way and in a bad way. And I was really interested. I got involved with Oregon Storyboard once I left Second Story, teaching a course on how to design courseware, educational courseware for trade education using the HoloLens, which is, I know it's a lot of words, but basically I'm teaching a course where we're going to build a holographic transmission, and automotive students in Clackamas Community College are going to use that to learn how to use automotive. So this is the HoloLens, so now you guys know kind of what it does. And now I wanted to share what we did. We had a hack day here with Portland Creative Coders. Those of you that were here, can you raise your hand that took part in that? So they are my truth, so you can talk to them if this is all bullshit or not. So much for that. I have the document. Let me get my. This is awkward because I didn't take a. Let's hope it's right here. Woo! You did a good job. So I want to talk about the HoloLens Art Hack Day. I don't want to talk about specifically the HoloLens. This is kind of bugging me right now. I'm going to look at you this way. I don't want to talk about the HoloLens as a device, but I really want to talk about mixed reality, holographic interfaces, and how we as designers and as creative coders can start thinking about those spaces. And right that the HoloLens is the device that really is the furthest along with it. It's not going to be the only one. Meta's coming. Google's going to come. Apple's going to come. Magic Leap's going to come. We're just getting started with this. Microsoft's opening their platform. They're going to license the hardware and the software to other. So this is not a one, let's look at Microsoft's platform and get happy about it. This is really about, let's move beyond that and start thinking about how we're going to blow each other's brains from an art perspective when it comes to this mixed reality that the HoloLens, that what they call SLAMs, I think it's simultaneous location and mapping. So the ability to put something on your head that actually knows where you are in this space without you being tethered. I'm tethered right now just because I'm streaming. and being able to create virtual galleries or galleries that are physical and interesting, but also have a virtual overlay. So I really wanted to get people involved in that. Oregon Storyboard is doing this training that I'm giving, this instruction, through a Microsoft grant. So Microsoft gave us a few HoloLenses. And so the reality is we only use those HoloLenses every Thursday evening. And so for the rest of the time, nothing's happening with the HoloLenses. And I'm like, that's a waste. We got to figure out a way that we use these HoloLenses more, and that people in Portland and in Oregon can start seeing, the future and starting getting it. So I'm really interested in increasing artistic exposure to HoloLens. Microsoft is having a very business-first approach, and they have many good reasons to do that. But I would love for there to be more creative and more creative coding input into, and art input into this holographic world, instead of it being just commercial business focused. So that's really what this is about, is like, how can we kind of open our minds and start thinking differently, not from it, how are we going to sell more shit, or how am I going to put more ads in your face, but more like from how can we artistically, and from our perspective, start challenging some of the preconceptions we have about our world. So I'm interested in doing more of that. I also wanted to explore easy ways to create for the HoloLens, and I'll talk to that a bit more because it's actually a bit of a bitch to build for it. And then I wanted to provide community access to HoloLens hardware. These devices are $3K, it's a lot of money. Not everyone wants to buy them. I wouldn't buy one, personally. But if I were a business, I'd buy one. A lot of us don't have access, especially from an artistic perspective. It's hard to make the case to buy something that is that expensive, and that is also requires a pretty steep curve if you're not into the Microsoft stack to get into developing for it. Ben is in my class, and Reed, who was here earlier, is also in my class. They can tell you all about how fun that is, and David is too, back there. So what? So on June 11th, we had 16 creative codists, artists, developers, you pick, and we gave them a constraint. And so what we've been doing with creative coders throughout the years, actually, we've run a few of these art hack days, and the way we run them is we pick a constraint, and we say, this is your constraint. We don't just get to come together, let's make art. No, it's like within the constraints and within rules, and by embracing those rules and pushing against those rules, that's how you can create interesting stuff. And so that's kind of the idea that we have for this too. And so the constraint that we had is we're going to give you a specific amount of space, 2 by 2 meters, because I'm Dutch and I'm not going to say feet. And so what will you create? So given a cube that's 2 by 2 meters, what will you create? And let's look at what we created. So this is a mashup of the videos of the captures from a HoloLens. Just like I showed you at the start of this presentation of what the HoloLens can do, you can actually record that, and so this is a recording of that. I'm not a motion graphics expert, so I just quickly put this together. So this is a recording just at the end of the day of people hacking. You see we're all sitting in the same space here, and it's loading up all these different, actually I think we have 6 or 7 different art pieces that are all playing in sequence. And the day was crazy, it was awesome. We had a flying duck every time you would put on the HoloLens, you don't know where the duck would be. So Ben worked on this WebGL phone interface where he would be able to stream across what's on his phone onto the HoloLens. And I'm just going to let the stuff speak for itself. I'm going to talk, and Ben might help me talk about how we built the plumbing to make this possible and easy and accessible for everybody to get onto. Duncan, who was going to be here, he's not here, he made this amazing duck, which is incredible. Look at the duck. It's flying. I mean, at first it was static, and we were very happy, but when it started to fly, it was magical. And I think he built this with WebGL. I had Duncan come back and take it, and then Surya, who's right here, he built these. This is all Unity. The colors are awesome. This one's a bit more creepy, but also loved. Same idea, but a different form, of course. And feel free to talk to Surya, Philippe, and Ben afterwards to talk about their experiences. This is Philippe's. He really embraced the physical aspect of this. Like, we could do something with, we could actually augment reality. So those are some of the results. That's kind of what I was able to quickly put together and capture. of the experiences that we had. So how do we do this? So to build for the HoloLens, to create any content for it, requires a Windows Pro operating system, which is not Linux and Mac, is the other one. Visual Studio 2015, Update 3, or whatever they call it. Unity 5.5 for HoloLens, not just the normal Unity. You have to get a special HoloLens that they update every 2 weeks. You need a HoloLens and you need a lot of time. So the problem that, as we were thinking about this, and I was brainstorming with Reed, the first thing we were out at Pins having a beer, the problem is most creative coders don't have this set up. For some reason, Visual Studio doesn't really invite that unless you're Open Frameworks or Cinder. Most people don't use that. So we didn't want to spend the whole day. I've been to some hacks where you spend the whole day, installing software, and then you get the last hour where you maybe get something done. And we really wanted to get people. The goal of the day was to get somebody going as quickly as possible. How can we get you creating a holographic experience stat? So we built some basic plumbing. So Ben, Reed, and I built some basic plumbing to allow creative coders to use tools and frameworks familiar to them to create holographic art. And the tools that we used were 3JS, WebGL, processing, and Unity. I mean, we could also build open frameworks and Cinder and what have you, and VVVV and Touch Designer, but these were the ones that we kind of thought were within our reach to build. And what we build is a mesh streamer. Basically, it's relatively straightforward when you think about the architecture of what we're doing. We're taking a front end and we're capturing the mesh. We have a little binary protocol that we came up with, format that we came up with, that sends it to a node server, and then the HoloLens retrieves it from the node server. And I'll give you guys a live demo of what that looks like in a second. So how does that work? This is my diagram. Processing Unity 3 and 3JS are the front ends. There could be more. There's no reason. They're using either WebSockets or HTTP to send the packets to Node. And then the HoloLenses, and there could be 4 or 6 or 10 or however many, are asking Node for that. And so the Node streams it back. We created the idea of slots, so you could subscribe to a slot, and a slot has a space, has a particular location in space. You want to talk about this packet format stuff and the...
Sure. So in order to keep the network traffic down, because we were going to have potentially a lot of clients providing mesh data into the system, we didn't represent everything that you might want to do with a mesh. We basically just had a bunch of vertices, and then colors for each vertex, and then a list of triangles, which were just indexing into the list of vertices. And so that's basically all you need to represent 3D geometry. We didn't have anything in terms of materials or normals or anything like that, but it was enough that we could get, you could create something in the framework that you're familiar with, and then just start sending frames to the HoloLens. And there's no ability to do any sort of fancy animation. It's basically every frame is a complete static mesh on its own. And so again, because of that, it was we were trying to keep bandwidth under control. I think when you have 5 or 6 channels really cranking, it was in the 4 to 8 megabytes per second, trying to cram over the Wi-Fi.
It's not scalable.
Yeah,
Don't do this at an event. Don't do it pure. It's not going to work.
Yeah, you're basically DDoSing the node server pretty hard.
It's Wi-Fi. There's a lot of bad ideas.
I don't know. Is Bill here? Bill's not here. Ah, shucks. The first Creative Coders Meetup I went to, Bill gave a talk about the most robust way to get a real-time, doing stuff on your phone to some sort of interactive experience. He basically just shot down everything fancy like WebSockets, and he was like, HTTP post. Nothing stops HTTP posts, and that's how this whole thing runs. We're just spamming the server with HTTP posts, and then the HoloLens is just getting over and over again, and it works.
So we're able to get everything you saw. We're able to get with right up here with what I wanted to show. It's the way it works: the vertex data, color data, and the triangle data. That's enough to be able to recreate a mesh on the other side. That's it. So it's relatively straightforward. That's how it works. It's open source too. I was going to give you guys a live demo of a sound visualization. We're going to see how it works, but just to kind of give you an idea of how it works in practice, how it's done in practice. So the problem is this is a small screen and you guys are sitting way back there. So I'm going to go through this relatively quickly and not get into the details because you're not going to see what I'm seeing right here. But in general, I built a Unity script that is dynamically creating a grid, a mesh, if you want to think of it as a single-sided mesh. And then I got Beck's latest song, Wow, which is awesome. And I'm getting the spectrum data from that song, and then I'm pushing it down that mesh. So that's what you're seeing. And hopefully, you guys can start, once I run this, you can start seeing that the visualization has some relationship to the actual audio as it plays back. For those of you that remember Winamp and back in the days when we had screensavers, and they were tied to your audio, like this is kind of me geeking out on that stuff. So what we see here is Unity playing and creating, and so this is going to be really difficult, let's see, because I need to use the Alt key. I'm not going to use the Alt key, I think. Let me just turn on, so you can kind of see that there's a flat plane right there, and if I turn the audio on, there you go, right? So that's a visualizer. Can you guys see that? Everybody sees it in the back, kind of? Okay, cool. So the other side to that is I should probably turn the audio down a bit. It's an awesome song. I've listened to it all day, and I still love it. So. If I look at the other side here, so this is the admin tool. Ben made this, it's awesome. And you can see that there is currently one slot defined. I only decided to find one slot because for the demo, I wanted to make sure that it would show up. But there could be 15 slots or 7 slots. I think we played up to 7 slots. And so we can see this is basically showing what Unity is sending, right? And so what I'm trying to show you guys here is that WebGL can be also, you could have done this all with web. It's just that I'm doing so much Unity these days that it's easier to do that. And so just like this web client is actually getting that data and displaying it, the HoloLens can do that too. So let's see if it's alive. It's alive. I'm going to turn this off for a dramatic effect. So we're going to go back to the somewhat nauseating live view. My apologies. So as you see, I can look around, and I'm seeing all these HoloLenses that we have placed here in the days past. And I'm going to now launch my streaming mesh app.
So yeah, can you make that any bigger?
Yes, I can. So that's the streaming mesh. It's going to start with nothing. Because I don't have the Unity app running, so it's actually going to say made with Unity. So it's pretty boring. Nothing's happening. I'm going to have to escape out of this for a second. If I try and put these side to side. So if I start Unity, I should see a big white plane somewhere. And with love.
Right in front of you, just look at it. Your left.
Oh, it's right there. Okay. It's not where I wanted it to be, but you can kind of see that there's one right there. Right there. Above you guys. Yeah, okay. Cool, right? So that's doing what we wanted to do because there's no sound. And as you can see here, it's straight and everything. And so when I start playing it, I'm going to turn the audio on. It's going to be awesome. You guys can't see what I'm seeing. One second. So I can walk around it. I'm not going to, I'm kind of tethered, but you can see the blue side is reacting to the bass, and you can start seeing the general shape of the song over time. It's a bit high right now, but if I would be able to look from the top, or more from the side, you'd be able to see it move around. that's what it does. We can talk more about this afterwards, but that's the general demo and the overview I wanted to give you guys. Any questions?
So what happened to the Microsoft stack? Does this node server does it read without any changes, or do you have to pre-program some firmware using that stack to get it to
So when I was in the HoloLens launching the app, I had to create a HoloLens app using that Microsoft stack to be able to connect to the node server. So what is running on the HoloLens is an app I wrote, which is taking the, retrieving the data, the frames from the node server, and then creating a dynamic mesh of that. So that's what you're seeing.
So theoretically, you can just bring these things to you.
Yeah. Yes.
And put that on.
And put it on that thing. Yes. Yeah. That's the idea. Yeah. And that's exactly the idea. Is that let's not get bogged down in what everything we can do with this device particularly. Let's get bogged down in the artistic thought pattern and the creative pattern behind what would you like to do. And then, some things the device is not going to do. It's basically a phone, so it's going to have a lot of challenges when it comes to performance and the amount of draws it can do. But in general, I think there's a lot of prototyping and fun that we can have, and reality bending experiences, somewhat hallucinogenic experiences even, just with the systems.
So I'm not really familiar with HoloLens. Can you does it take user input? Like if you walk toward an object,
Yeah.
can it realize that?
It can, yeah. So let me show if I can see if I can demonstrate that. The problem is I'm tethered. The reason I'm tethered right now is because I'm trying to show you guys this with the lowest latency. That's the only reason this is plugged in.
So you can program Pokemon to run away from it.
You can program, yeah. So it's going to be difficult to show this, but the problem is because I'm plugged in, I don't have much of a port. But if I get closer or further away, it acts as if it's a real object. So it's, what the HoloLens is doing is it's actually scanning the space in real time. So there you can see what it's doing. It basically has a Kinect built into it. And so when Elon saw this, he figured it out. He's like, we are in the Matrix.
So it's taking a point cloud and
Yeah.
connecting it?
Yeah.
Very cool.
Yeah.
With like 6 cameras or something.
It has a bunch of cameras, and so it's doing a continuous map of the space. It's building like a Kinect with, right? Building an OBJ. Let me show you guys how that works. One second. This is what's called a device manager. Sorry, there's a dog that's barking here. This dog is bugging the crap out of me. Let me show you guys. This is the new life. This is it. That's why. Is it gonna work? Well, I shut the dog in. Even if that's not gonna work. That's what happened. One second. Demo time, right? I'll show this guy because I think it's relevant to think about this environment. Now, let's not get hung up on the HoloLens. HoloLens is great. Awesome, thanks Microsoft. Google Tango is doing this. Apple has bought a whole bunch of companies and patents and stuff like that within this space. And Magic Leap is doing this too. NVIDIA is really hot on this. Qualcomm is really hot on this. Intel is really hot on this. So it's important to not be blind to this device itself and its limitation. And it's really important, especially for us as creative coders, to think a bit larger and to think a bit bigger and start imagining what we can do with it in the anticipation of better devices, better stacks, more user-friendly, more developer-friendly, all that type of stuff. It's all going to get there. What we're dealing with is a development type of thing. What I was going to show you is that, so what this is showing right now on the screen is it's asking the HoloLens to retrieve a few meters by a few meters the space that it's in. And so you can see this is its current understanding of its space. I don't know if that makes sense to you guys, but it's basically doing relative real-time scanning. But you can also see that it's kind of lost its resolution further out. So it sees Philippe, sees about 3 meters out well, and then after that. But you can see that it's actually So like if I move up, if I look up, you can see the cone go up and down. And so that's because it knows where the floors and the walls, and that's how it can stack stuff against that. Sorry?
Windows and translucent things. It suffers with everything that the next suffers with because it's doing iron. So certain materials are just invisible.
The interaction is really very simple. You can tap on things. So here's a dog. That's the dog. It sits up and it's a cute dog. It really is. You can see it's a bit of a big dog, right? It's large. So what I need to be able to do is adjust the size and make it a bit more manageable. Sorry.
Funny, I shrank my dog.
I shrink you. And I can move it, so it's like going to be right there for you guys. So now you can see the dog. Oh, I removed it. There's a window up here. What you find yourself doing, you're like, where's that window? Or today, Nick can attest, is like, I was saying a lot of, crap, I lost my art. Where did my art go? And then I'd be looking around as to where it is. But this is the dog. Yeah. So if I, there you go. That's cute. It's a bit of a low poly dog, but it's a dog. What I wanted to show is that it does know where the floor is. I can't place the dog underneath the floor, which, if you start thinking about it, is actually pretty ridiculous. Awesome. That the whole interface understands where the floor is, and that it simply doesn't allow me to take this completely virtual object and push it through the floor, which is what you would normally do. If I would make something, which is it would drop right down the floor. But it does collision detection with the real world, and that's an interesting thing. So, oh, I should make it huge.
But that would be God mode.
I think it would be ghost mode.
Anyway, that's if you want to know more about HoloLens, there's a HoloLens meetup here next Monday. So I would recommend coming to that. There's a lot of HoloLens developers in that you could talk to and learn more about. And then sorry, it's Monday, next Monday. Yeah. Okay. It's on the board too. It's going to be here next Monday. It's here. And then also, I'm going to pitch again. We are running these day-long immersions in VR and AR, and like the HoloLens, everything I'm showing you guys, that's part of that. So you get to put it on and play with it for an hour, and do all these different experiences. Do Galaxy Explorer and Robo-Raid and Holo Earth and what have you. There's many different experiences that it's worthwhile going through. So if you're thinking about what could I do with this from a business perspective, that's worthwhile. I'm continuously trying to figure out, like, how do we run, Ben and I were talking about this yesterday, we want to run another art hack day and really get into more of a rhythm as to how can we build something that's simple that we can prep you guys on so that you can be thinking, okay, what can it be? And you can come in and play with it. And maybe we can even have a show at the end or something like that. But that would be my, that's what I really am very excited about. So that's it. Thank you guys. And thank you, Beck, for that awesome song. Sorry for using it without his permission.
All right.
All right, well, thank you, everybody. We've got the space for about another hour. I don't know, there's probably beers left. I think we've got a secret beer supply. If there's not, we can replenish. Just to reiterate, this new landscape that's opening up with AR, one thing that I didn't realize when I first heard about the HoloLens, and this is true of the other headsets, is that like this cable, unlike most of the VR headsets that we're seeing come out now, like it's all happening in the device. Like you can go outside and walk down the street and all of this stuff is still going on. Like we're on the cusp, I'm going to get like weird and futurist here, but we're on the cusp of a very interesting shift in the way technology is going to be able to present itself to us. And it's pretty exciting. And I feel like there's a landscape opening up. Like nobody knows what the hell to do with this yet. Everybody gets that it's like very different and very potentially transformative, but like nobody's really dialed it in yet. And so the landscape is open in a way that doesn't happen very often, in my opinion. I kind of compare it to like when the App Store was a thing. Like you could have one person make an app that was like, oh my god, no one's ever made that before. And now it's sort of saturated to the point where you really have to be more of like a serious full-time, usually large organization to break into such a saturated space. And you really only get that chance where the landscape is open to the horizon, and that's happening very soon. So really exciting stuff. Let's drink some beers and chat.